Good morning, afternoon, evening, whatever it is for you at the moment. Let's talk about PyScript, and especially the new release version 2023.3.1. I'm Jeff Glass. Let's get right into it. A couple little bits of housekeeping as we switch over to the code. As always, this is live for a reason, so if you have questions, comments, concerns, things you want to talk about, stuff you run into, please let me know in the chat here on YouTube, and we will see if we can address it. The other thing is, of course, the big old monitor that I'm viewing this on might be different from the device you're viewing this on, so if you want to see things a little bit closer, if the text size is not right for you, or whatever you have, please do feel free to let me know, and we'll see if we can adjust, because the whole point is that y'all can see this as best as you can. If you are watching this after the fact on YouTube, I will put channel time markers or chapter time markers down in the description, so you should be able to jump ahead to some section that interests you the most. I will do my best to make, was it over on this side? No, it's over there. Make this little chapter marker be updated in real time, so hopefully you can just scroll forward till you find the thing that interests you. I'm not the best at remembering to update it, so we'll see how good we can do there. But the chapter time markers will be accurate, so you can always rely on those. Yeah? That's all the preamble there is. Let's talk about PyScript and the new stuff that came out in the March release. The first thing I want to talk about is PyScript tags have a new attribute, the output attribute. So let's take a look at what that looks like. Here's my development stub we'll be using for today. It's got a lot of other shenanigans in it, but I'm just linking to the 2023.03.1 release right here in my script tag and my link tag. As always, I want to take this opportunity to advocate that you link to a pinned release and not to the thing that I see a lot of people doing, and I know it's what our documentation recommends, which is linking to /latest. And the reason you shouldn't link to /latest, I mean, it's fine if you're just messing around or doing an experiment, totally good. I get it. It's fast. It's easy. But if you are linking to /latest for a project, then 2 Fridays ago, we broke your code. When we pushed a new release, everything updated, and I guarantee there is stuff you were relying on that broke. I guess this is slightly less true for the 2023.03.1 release than for the December release. That broke everybody's code. So always link to a pinned release, and you'll be much happier that you are not getting changes sort of changed out from under you there. Sorry, I'm just going to pull up a couple of other windows on the side to make sure everything is copacetic, and it looks like it is. So let's talk about the output equals parameter. Down here in my body of my HTML document, I have my PyScript tag. I'm using a source equals reference just to pull in some code from my additional .py file, and this way I get linting, I get code completion, I get all those nice things. Honestly, I am rarely putting code inside of a PyScript tag directly. Except for the case of writing tutorials or snippets to post on the web. Almost all the time I'm going to be linking to an external file just because it allows such a better development experience. So this is the document we'll be using for today. PyScript tag in demo.html for what it's worth, linking to demo.py, and that's the code you saw pop up when we started the day. Oh, that's not what you want. You don't need to see my live chat. You want to see this window, my development stub. So you can see that if I update that code, I'm just running a little live server to keep this updating, printing by 10 times, right? So that's what we're working with for today. So in the 2022.09 release, we released the display built-in function. And the display built-in function, as a reminder, is the thing that you want to be using if you are outputting the results of a Python operation to somewhere specific in the page, in the DOM, as it were. And that's because, so the print statement, Python's print statement, is meant to output text to a stream, right? To a file-like object that it writes, content out, broken up by new lines, and that shows up somewhere, maybe in your terminal, maybe in a file, something like that. The DOM is not really a stream of data. It's much more involved, complex, interesting than that. So we added this display built-in that allows you to be a little more specific about where your content goes. So if I just do display with no additional parameters, I just give it a string or some string-like content, it just shows up in the DOM, sort of underneath where the PyScript tag in the DOM would end up. And actually, you can see this if I put a couple of paragraph tags in here. We should see hello, goodbye, and then Jeff is cool should end up in between them, right? So the PyScript tag is in between the hello and goodbye in the DOM. And so the default location of output is where the PyScript tag is. But of course, the power of the PyScript tag is that you can put that content in other places. So if I have another DOM element with a separate ID, let's call it my target. If I use the target attribute of the display function, say the string, my target. Oops, and we actually write it right and don't put an extra parentheses there. None type object has no attribute append child. So what's happening there is display can't find. Oh, I didn't save my HTML document so that the element didn't exist, right? So now what's happening is when we run our demo.py function, we're taking the string-like content and we're sticking it in the element in the DOM with the ID that we specified by target. And that's this one down here. So we should see hello, goodbye, Jeff is cool. And that is, in fact, what we see on the right. So this is all well and good. This is all true as of 2022.9.1. But what if we wanted to take a program which is using standard out to do some specific kind of output and wants to put that output in a specific place? The sort of canonical example we were working with is import this, which if you haven't tried before in your Python REPL or in your source, just prints out the Zen of Python into your standard out into your terminal here. Beautiful is better than ugly, explicit is better than implicit, like words we should all strive to live by in our Python code if we have. So import this is using, I believe, print under the hood. It's just printing out this text. But currently, previously to 2023.031, I should say, there was no way to take this text, which Python is printing, and put it somewhere specific in the DOM. It's writing to standard out. Standard out only goes to our PyTerminal. There's nothing really we could do with it. And we could, there are ways to work around this previously, right? You could use a context manager, right? You could say from sys import, standard out. We could wrap standard out in a context manager, or there's some built in. You could say, okay, print this to, I want standard out to go somewhere else. It was a little bit convoluted. So what we've done is add an output attribute to our PyScript tags. And I'm going to reuse the div my target that we invented before. And what this will do is say any writes to standard out, and I should say standard error, stderr, sys.standard error, any writes that go to there will now also be routed to the element in the DOM with this ID. Right, so if I save this, what I should see is, yes, so again, I have hello, goodbye, and then my target div, and what my output attribute has done is taken hello, goodbye, and then it shoved the output to standard out, the contents of my print statement, and put it into that div in the DOM. If I inspect this, even bring up our quite large terminal over here, we can see that this div, my target, is the one that contains the Zen of Python now. So what this is intended for is if you have a piece of Python code that you've written, not for PyScript, just want it to run on your desktop, and it's doing interesting things with standard out, if you're printing things, and you want those print statements to go somewhere specific when you run it in PyScript, if we, in our example, our interesting code is import this. If we want that output to go somewhere specific and not just to our sort of pre-formatted PyTerminal, you can use the output equals attribute to control where that goes. I should note, if we come back over here to our example, that by default, make it a little bigger, by default, it is also going to the PyTerminal, right? So it's going to that element in the DOM with the ID that we specified, but it also goes to our terminal. So if you don't want that, you may need to hide it in pyconfig terminal equals false. I believe is the syntax for hiding the PyTerminal or not creating one in the first place. Yeah, so now that standard out is only going to that one element in the DOM that we specified. So a useful thing, we're trying to make it easier for people who are writing code that was meant to run not in the DOM or not in the browser to run in the browser in a visually interesting way. Yeah? Let us see here. What's next? So I think that's all there is to say about output equals. Let's talk about plugins. We're going to be jumping around a little bit between sort of the new features and the features that are coming today, but I want to address them in like sort of order that makes sense to me, and hopefully it will make sense to you after the fact. So let's talk about plugins, because there were some pretty significant changes to the plugins architecture in 2023.03.1. And we touched on this a little bit last stream. Oops, that's my live chat popping up again. Make sure we get the right window there. So what is a plugin in a PyScript sense? And I will be the first to say we have not done a tremendous job of advocating users to use this. It's a super powerful feature. You can do tons of things with it. And I'll be honest, so every couple of weeks we have a call with the PyScript team called PyScript Fun that we just like share cool, weird things we've made. And for about 3 of those straight, I was like, I made a plugin. It does X, Y, and Z. And after that, Nicholas, who is often our host for these things, said, why don't we try to make things that aren't plugins next time, which is totally fair. But I love them because they're a super powerful way to use and integrate things with PyScript. So what are they? And what are they now in 2023.03.1? I think the simplest way to show this is actually going to be to take a peek inside the PyScript codebase itself and show you a little bit about the operation order of what PyScript is doing when it runs in your page. So I'm just going to open up, I'm doing this from within the PyScript codebase. I'm going to open up main.ts and give you just a little peek into what happens when you run PyScript. So let's switch back over to the code. So in main.ts here, we're going to do about 400 lines of setup, but what you need to know is at the very end of the file, the same way that we might do like a, if name equals main, then run some function, our equivalent is here is we do, 381 lines of setup, and at the end, we create a copy of this PyScript app class and call its main function, right? That's the entry point to PyScript as a JavaScript module. So what is main? Well, if we jump back up here, this is the main method of the PyScript app class. And it's a little bit cheating because actually what we're doing is wrapping the actual main method, the real main method, in some error handling. So if we have Python errors anywhere inside of this, we get some nice error handling. So let's take a look at real main. Let's jump down to that. Real main. So this is when PyScript runs in your browser, when you include it via a script tag, this is what happens first. First thing we're going to do is load the configuration. So that's going to find our pyconfig tag. You can see it down here. It'll load our pyconfig tag, load all the properties you define so we can use it to do other things within the browser. Then it's in our real main function, we have this.plugins.configure, this.plugins.beforelaunch, and then load interpreter, and other things will happen after that. This.plugins.configure and this.plugins.beforelaunch is the syntax I want to focus on here. This is saying that for every plugin that we have installed, I know I haven't told you what a plugin is yet, I just want to show you how they're used. For every plugin we have installed, call its configure method and pass it the configuration we just loaded. Once that's done, for every plugin we have installed, call its before launch method with the configuration that we have installed. Right? So there are some plugins that are built into PyScript, and I believe, let's see, what's the best way to show this? So in our main.ts here, when we actually initialize our PyScript app, when we run our constructor, we actually add a bunch of built-in plugins already. Splash screen plugin, PyTerminal plugin, import map plugin. We have some stuff to handle sort of the standard I/O, so that's the standard out and standard air functions, various things like that. So for each of these objects, when we run that main function, we will first call its configure method and then its before launch method, right? So for something like the splash screen plugin, the configure is responsible for, reading the parts of the pyconfig and figuring out what it wants to do. Should it automatically close? Should it be shown at all? Before launch, in this case, this particular plugin is what's responsible for actually adding a splash screen element to the page. That's that spinner that you see when PyScript is loading that if you've been working with PyScript at all, you're quite familiar with. So, right, so a plugin in an internal sense is just an object, in this case a class, that has some attributes that have some specific names, like configure, like before launch. There's some others we'll see in a little bit, like after startup or after launch. And at certain points in the PyScript lifecycle, PyScript calls all of the plugin objects that it knows about. It calls the specific method on those objects. So it goes through and calls configure on the splash screen plugin. It calls configure on the PyTerminal plugin, and that sets up the PyTerminal and things like that. So that's all it is. A plugin is just an object that has some methods with specific names that we call at particular points in the PyScript lifecycle, right? So far you're like, Jeff, this is cool, but how do I use this? These all look like they are internal. Aha, no. You can write your own plugins and install them at runtime in PyScript. So let's look at how we would do that by implementing a very simple plugin. So let us create a new Python file. And I should say, this is one of the cool things about 2023.03.1. You can now write your plugins in Python, or if you want, in JavaScript. There are some slight differences between them that we will get to. But I am going to start a new file. You probably can't see my little file picker there, but I'm going to call it noawait.py. That'll be my new Python file. And I'm going to invent a plugin here, and this is a tribute to some of our PyScript team members who think that async await is not something that users should be required to use for good functionality, and that it is a path to madness. I personally disagree, but you can imagine a situation where you'd want a plugin that if you install it in your PyScript page, if someone tries to use async await anywhere in any of their PyScript tags, it shows a warning to the user, let's say. We won't flesh this out entirely, but that'll be the premise. We want a tag that says, hey, when you go to run any code, show the user a warning that they shouldn't use async await because async await is bad, or something like that. Not my opinion, but here we are. So a plugin in Python works like this. Let's create a new class that's going to have those callable methods that'll be called at certain points in the life cycle. We can call it whatever we want. We'll call it my await. Let's call it something more evocative. Await evil will be the name of our class. Python plugins are required to have one method, which is called init. It doesn't have to do anything. And this is, I should say, separate from dunder init, which is what Python is going to call when we actually evaluate this class, when we, construct this class. The init method is going to be called when the Python plugin is added to the runtime of PyScript itself. So this is going to be the earliest interaction that PyScript and our Python class have. I'm actually going to not do anything with it, but it is the one required method of our class. And then, just to show you this actually works, let me create a configure method that is going to run when PyScript calls configure on our plugin object. And to make it as simple as possible, here, maybe I'll just use print. We'll just say print, trying to configure the await eval plugin. Right? So not doing anything terribly useful yet, but as a demo, this will be a place to start. And then the one last thing we need to have for PyScript to be able to know how to use our class is we need to have an object in the namespace of this module, right? This file called plugin. Essentially, the way that PyScript is going to grab an instance of our plugin and use it is it's going to do, import this Python file that we've named, and import the plugin object from it, the object called lowercase plugin. So there's literally a statement that says, from some module name, from noawait.py, import plugin, and that's going to be the object that we use, right? So now how do we tell PyScript that we want to actually use this noawait.py file in our PyScript app? We put a tag in the pyconfig tag, or an attribute, I should say, called plugins. And plugins, at this point, and this will change, takes a list of URLs to the modules that we want to import. So I'm going to just remove our import this to make things a little bit cleaner. And we'll have it just run a little bit of demo code. Now, I can see PyScript is crashing over on the side here, and I'm curious why. What is happening here? Type error, await eval.init takes one positional argument, but two are given. So we're passing something to init that we don't want to use. I'm just going to star args that just to make that function signature happy. And we'll run a little Python startup. And what we should see, let's see here. So we can see if we look in our console that if we look in the section about what plugins we're going to fetch, it found our noawait.py. It said it was fetching it, and then it was importing our object from it, and all the plugins were fetched. Now, interestingly, okay, so this is right. I'm following along with my little lesson guide over here, and I've laid a trap for myself, which is the configure function, though it is available to internal plugins, is not available to Python plugins. It's available to JavaScript plugins, but not to Python ones. And the reason is, in the lifecycle that we were looking at earlier, where we had real main, the plugins.configure method gets called almost immediately when PyScript starts. It actually gets called even before we have a Python interpreter to work with. So configure is not available to Python plugins, neither is before launch. So to show off this actually working, we'll want to use something that's much later in the lifecycle, like, I believe, after setup. is quite a bit later. There we go. So after setup takes place basically after all of the interpreter has been loaded and is ready to run any PyScript tags, but hasn't run them yet. And so we can see that after setup method of our new plugin did run, and it ran before any of the PyScript tags actually were evaluated, right? So we have basically the ability to do things to the page, to the DOM, to PyScript before our PyScript tags run, and after. But that's just what we could do in this case. So the actual list of plugin methods that are available is not, I will confess, super well documented anywhere. The best thing you can do is go to this plugin.ts file in the PyScript codebase, sorry for the scrolling, which defines the plugin class. And in that, we have references to all of the available plugin methods. So we have configure, before launch, after setup, and then a couple that I think are really cool. And I'm humble bragging because they were both from PRs that I pushed to the codebase. Before PyScript exec and after PyScript exec. These before PyScript exec and after PyScript exec methods are a little bit different from the other lifecycle methods that sort of run once as PyScript is loading. These will run immediately before and after any individual PyScript tag runs. And you can see it is being passed a copy of the Python interpreter that we have available, the source code we're about to run, and a reference to the PyScript tag itself. So that if we want to, do something with it before or after the code runs, we absolutely can. The after PyScript exec tag takes the same things, but also gets the result of the PyScript tag. That is in the sense of, the last line, the last expression in your PyScript file. The result of that will be passed as this result argument to after PyScript exec. So going back to our goal here, which was, if somebody is using async await in their PyScript tag, and we want to at least shout at them a little bit that they shouldn't. This is for you, Antonio. I could add a before PyScript exec method to my plugin. And I'll just do this as ** kwargs to swallow up all those positional arguments. I should say, as you're looking in plugin.ts, all of these options here, and this is, of course, a TypeScript, a JavaScript file. When we pass these arguments to the Python side of things, these things get passed as keyword arguments. In JavaScript, they get passed as an options object, which is the more JavaScript-y way to pass multiple arguments. In Python, we pass them as keyword arguments. So I'm going to get a keyword argument for interpreter, for source, and for PyScript tag. So back in our plugin here, I can say source equals kwargs src. And how are we going to show this warning? If, let's just say if await in source, print, hey, you're using async await. Right? That's not the most thorough test of whether we're using async await in our code, but I think it will do for now. So let's just make sure we can see what's actually happening. I'll say if we're not using await, we'll just print a little smiley face. How's that? So here's what's happening. We can see the after setup method of our plugin is still running. When we went to run our singular PyScript tag on our page, we scanned its source to see if await was in it. It wasn't, so we printed a smiley face. If we go into the source for our PyScript tag now, and I even just in a comment say, hey, I like await, right? What we should see now is, hey, you're using async await. It's throwing up a little bit on us as we're trying to do it. So this is obviously a very primitive example of what you can do with a plugin, but you have this opportunity to, from Python, do some setup at some various points in the PyScript lifecycle, and then add these additional interaction methods sort of before and after every PyScript tag. To show you the after tag as well, let's say result equals kwargs result. And let's say if my PyScript file, if the last expression is, I don't know, a string, we'll do something. If it's not a string, we'll do something else. So we'll say if type result equals string, print it was a string, else print not a string. Right? So this should run for, again, immediately after any PyScript tag finishes executing. We can see that so here's an interesting thing about operation order, right? So we ran our after setup method before any of the PyScript tags ran. Then when we got to running our PyScript tag, we first called before PyScript exec. It yelled at us about using using async await. Then our PyScript tag ran, which is where that this is a file declaration is coming from, right? That's inside our PyScript tag. And then afterward, after that script tag was complete, we ran this after PyScript exec method. And that's where we get our additional PyScript method here running. So now if I want to say, see that the result is actually being read as a string, I would need to have the last expression of our PyScript, our Python file here be a string. This may look a little bit strange, right? Because it was a string, yes, the last expression here. And right, so this is the last expression, not the last statement. And this is a slightly odd thing to be doing in a PyScript tag, right? Like, why would we just have a dangling foo here, right? This is one way if you need to like get the contents out and handle it with an after PyScript exec method, you could like do something like this. Just put the values, if I have x equals foo and then just x, right? Then I'm returning the value of my PyScript tag in a way. This is much more commonly, though, what you might see in a REPL. And this is not something that is currently in PyScript 2023.03.1, but we've just merged a PR, so it's not in this version, it'll be in the next version, that does allow you to react to the contents of REPLs. So if I say git checkout main and pull myself back onto the main branch and look again at this file, we'll see that in addition to before PyScript exec and after PyScript exec, we now have before PyREPL exec and after PyREPL exec. So if you are one of the people who have been asking us, hey, how do I take some action based on what the user has done in the REPL, right? I want to make a quiz where if the user I want to challenge them to like write a list in the REPL and then execute it. How do I tell what that has been? What is the result of that REPL? The way you would do it is to write a plugin, which probably uses the after PyREPL exec hook and looks at the result of executing that REPL. Right, that would be one way to do it. You could also say, like, if you're not necessarily looking for the user to use the results of that REPL, but just create an object, you could write a hook or a method for your plugin object that says, what would it say? Oh, when this script fires, look at the interpreter, look at its globals dictionary, and if the user has added a new list to the global object since the last time, then we call that a success somehow. We one way to do it, right? So this is the gist of Python plugins and PyScript. There is an object which has attributes which are callable, which have specific names, and at certain points in the PyScript lifecycle, PyScript will call those methods and pass them some parameters, and then you can have it do whatever you want, right? That's the gist of it. I will also note, so like guys mentioned, you can write plugins in JavaScript as well as Python, which might be really useful if you're doing something that requires you to do JavaScript-ish kind of things. One of the demos that I did on one of these, demo days was to incorporate Xterm.js, which is a fully functional graphic terminal, into PyScript by way of a plugin, right? So I wrote a plugin in JavaScript that, allowed itself to be loaded into PyScript at load time and then use that as a terminal instead. I'm not going to re-implement that whole thing here, but what I will do is show you just very briefly how JavaScript plugins work. So let's create a new file. We will call this tempplugin.js. And where Python plugins require an object called plugin in their namespace for PyScript to be able to find and import them, JavaScript has a slightly more a cleaner way of declaring what they want to send out of any given module and be used by other things, and that's the export syntax. PyScript will look at the default export from your file and use that as the object with callable attributes that it's going to look at. So in this case, I'm just going to look at, I'm just going to create an export, a class. It's going to be the default export of this file. I'm going to call it my JS plugin. That's going to be our temp name for today. I could create a constructor for it, which I don't actually think I need to use at all. And then in this case, let's just use our before PyScript exec. We'll take an options object again, and then we will just js.console. Oops, I don't need to do JS because we're in JavaScript. Console.log options.source. So before we execute any script tags, we're going to log the contents of their source to the terminal here. And what we would see if I had actually included this in my plugins list is it would show up here, but we will need to do that first. Similarly to how Python plugins are included, you just give a relative URL to the plugins, or I guess I should say, could be relative or could be an absolute URL, just a URL. Give it to the plugins key. At the moment, the way that we're disambiguating which plugins are Python and which are JavaScript is by their suffix. So if it ends in .py, it's a Python plugin. If it's .js, it's a JS plugin. And we'll see that over here, if we scroll up to where we're fetching plugins, we found two plugins, noawait.py and temp.js. We fetched our Python plugins, then we fetched our JavaScript plugins, and we installed them. And if we scroll down a little bit, we should see, yeah, so before we executed our PyScript tag, we actually just printed out its source to the console over here. That's the same source that we have in our PyScript tag. And because our before PyScript exec hook ran, before that script ran, we're seeing it before any of the outputs that are actually coming from that file. And again, this is available. There are numerous methods available before setup, after setup, before PyScript exec, after PyScript exec, and so on. But that is the gist of plugins. If you have a JS plugin, the default object that you export from that file will be used as this object with methods that are getting called. If you have a Python plugin, where's my Python plugin? What do I call it? No, oh wait. With a Python plugin, you need an object called plugin in the namespace of that module that is the object that has those callable methods. That'll be called at various places in that lifecycle. Cool? Questions there? I need to take just a 2 seconds for water because that was the most involved I think we've gotten so far. And then after that, we will dive into the next thing. Now, as usual, I have forgotten to update my little scroll on the bottom here. Ooh. So the next thing we'll get to is using PyScript to access the user's native file system from the browser. It's a very cool thing. Give me 2 seconds. And we're back, and we remembered to unmute ourselves, which is a really good thing. Oh, very cool. I love plugins. They're super, super powerful. When you start thinking about the ability to add additional code to run alongside your PyScript tags. But let's carry right along. Let's talk about native file access. Let's clean things up a little bit here. I'm just going to reset to my sort of default PyScript stub file here. Let's go back and clear out demo.py, and we'll talk about native file system access. So, Chrome and Chrome only, well, Chrome and Chromium, so it's actually quite a few more things, Edge has this now as well, have the ability to ask the user for permission to read and write from their local file system without uploading the files into the browser, which is kind of scary and kind of awesome. And let me show you how this actually works. I'm not going to try and reinvent this from scratch. I'll bring in sort of, the cake I baked earlier in this example. Let's make that a little bit bigger to show you how this works. So here we have an async function called request and print folder. There's a fair amount of things in it, but the key method I want to look at is this show directory picker. When you call show directory picker, which is a JavaScript object, a JavaScript function that we've imported from JS, when we call it, it's going to ask the user to pick a folder on their computer or on their device, I guess. I haven't tried this on mobile Chrome. I wonder how well it would work. Ask the user to pick a folder on their device that Chrome, that Chrome tab specifically, is going to have read and or write access to for as long as that tab is open. Which is really cool. So we can see here, once we've asked Python's going to get a reference to the folder that the user picked. And we're going to take a second to say, okay, do I have permission to read from that folder or write to that folder? And to specify that the mode is correct, I've used this syntax to basically create a JavaScript object that has the properties that we want. Basically say, if we don't have read and write permission, in this case, I'm just going to raise a Python exception that says, hey, I need these things for whatever nefarious purposes I have. If we do have read and write permission, I can use this new function in Pyodide 22 called mount native file system to mount the folder in the user's local file system, like on their hard drive, on their computer, directly into the virtual file system that PyScript and Pyodide are looking at, and then I can do things with it. So to just to give you a sense of what's happening there, let's add one more line. We'll say for if we do get access to this native file system, then I want to print out everything in the virtual file system that I see in the local file system. If this is not quite making sense yet, give me 1 second to show you the demo. Get out of there. Give me 1 sec to show you the demo, and I think it will. So let's refresh this, and we'll see if the zoom makes any sense here. Why are you not? Oh, you know what I've done is I've created this function here, but I haven't called it anywhere. And this is actually something that's important to know if you've not done that much development in the browser. I believe, and we'll find out if this is true, show directory picker is something that you can only call in response to a user interaction. So I think even if I import async.io and try to run this function from within PyScript sort of on page load, async.io.ensure future, we crest and print folder. Right, this should basically just run our function as soon as the page loads, and I think it's going to not let me. Let's see if it brings up any particular errors. No, not so much. So it's not giving me a visible error, although that could be a PyScript issue, because we are swallowing errors in coroutines. So this is not doing anything. What we need to do is give ourselves some way to run that function in response to a user interaction. So let's use our old favorite pyclick, and we're going to pass it an executable string of our function. There's our button. So now let's see if this works. So if I click that button, haha, there we go. So it has opened a file browser to my desktop or to my computer. I know this is a small size, but you don't need to see all of the files on my computer anyway. So I prepared this data folder earlier. If I select that folder, it's going to pop up with a little message that I will read to you because I know it's small. It says, let site view files. http://127.0.0.1 will be able to view files in your folder data until you close all tabs for this site. And I have view files and cancel. So I'll say view files, save changes to data. Your localhost will be able to edit files in data until you close all tabs for this site. So I'm going to say, yes, I'm allowing this web tab to edit files on my computer until I close this tab. Again, this is a super powerful, slightly scary feature. So if I say save changes, okay, it's going to carry on, and it's going to list the 2 files that are in that folder on my computer, because it has been able to mount them directly into the Inscription virtual file system. So these 2 files now exist in a place where PyScript can access them. Right, I have this data file of bright stars in the sky. I was just looking for data. I have a list of all the national anthems of the world. And to prove to you that I really do have access to them, let me add a little more pre-written code to my function over here. I'm going to say, take my mounted file, mountdir.nationalanthems.csv, right? So this is a reference to the virtual file system inside my browser, which now has a reference to my local file system. I can say, if I have access to it, open it up, grab it with our normal CSV reader, and print out the first 5 lines, right? This is all just normal Python for how you'd interact with a CSV file. But we can see here that, yes, give access to that same folder. Yes, give it access. Yes, give it access. And now it grabs that CSV file off of my hard drive and prints out the first 5 lines of it, which I guess are headers, and then the national anthems of Albania, Armenia, Australia, and Azerbaijan, which look to be quite stirring and quite long. Right? So that's the gist of it. Using this mount native FS system in combination with JS's directory picker, you can give your PyScript access, if the users will allow it, a reference to a specific folder on their desktop. The way that I see this being used is if you are creating an app that is meant to reference several pieces of user data. Let's say you're doing a data visualization app and you expect the user to be able to provide a data file, a metadata file, maybe a couple of images. Maybe you're doing some checkpoint training on a multivariate thing. You could have 4 or 5 separate file upload slots on your page for those different kind of files, or maybe one, and you try and figure out behind the scenes which file is which. Or you could say, hey, put all that data in a folder, make sure your files are named, data, metadata, file thing, and then just click this button and give my browser tab access to that folder for the context of this page, and I will just grab the files out of it as I need to. And if you want to, you can have it write data directly back to their hard drive after the operation is completed, right? So you can do, essentially the user has the option to allow the browser tab to do some data manipulation directly on their disk without having to do upload or download or any of that. Super cool, super, super powerful, a little bit dicey. But I do want people to explore playing with this because I think it's going to be a really cool dimension to add to PyScript apps. So that is the native file system. This is mostly, I should say, a thing that has come along because PyScript is upgraded to Pyodide 22 instead of 21 that came along with that. And the next few things we'll talk about are also sort of in a similar vein of things that Pyodide, the Pyodide runtime, brings to PyScript. One of those things is, and I can see my header over here. Cheech that down a little bit so we can actually see those headers. So we can see that the next thing is the Pyodide HTTP package. This is super cool. It's going to be a quick demo, but I think it's going to be really valuable for all of y'all. Let me clean up my HTML and my Python a little bit, and I will show you what it does. One of the most common I don't want to say issues, questions that we get coming through the Discord or through the GitHub issues or GitHub discussions is, hey, I want to use the requests library. I understand that in Python, the requests library package, whatever you want to call it, is the way that I get stuff from the internet. But I put this in my PyScript app and it doesn't work, and I'd like it to work. How do I make it work? And the answer for a long time has been, oh, you are kind of out of luck because in the browser, we don't really have the access to the same sort of networking primitives that you do on a desktop environment. So requests, though you can import it without it erroring, it's kind of been neutered. It doesn't really do anything. You're going to have to find another way. And that's kind of a bummer. So let me show you, if you've not worked with requests before, here's a really simple example of how you use it in sort of desktop flavored Python, right? You use the requests.get method to get something from a URL. In this case, this is just a dummy API that I can use to get data from. And then once you have that request, you can pull things off it like the status code of the response. If it was a JSON response, you can, get the JSON response out of it as an object. But you can see already over here on the right-hand side of your screen, we're having a URLlib3 exception, can't connect to HTTPS URL. This is that sort of like limitations of the browser thing that has always sort of been true in Python and PyScript, even though this exact code works just fine in the desktop. So if I open up my terminal down here, and I can make that a little bit bigger, I can say Python, and let's see if I remember stream demo.py. So and this is just a Python terminal. I'm going to run this in my terminal here, and we can see it made that request just fine. It got the sort of dummy contents of that request, got the status code 200, which means it was a successful request, got the title back from this API. So it works just fine on your desktop. It doesn't work in the browser. That's a bummer, because that's what PyScript is meant to do, run Python, any Python, big star there in your browser. Thankfully, we have a way around this now. And by we, I mean the Pyodide team and Cohen, K-O-E-N. I'm so sorry if I'm mispronouncing your name. I think your package is really cool. And the package that he's created is a package called Pyodide HTTP, which provides some monkey patching, if you will. Maybe it's just patching. Some patching in the browser for common libraries that we might want to use, like requests. So in order to use it, what we will do is add Pyodide HTTP into our packages list. And then in our Python file over here, before we do import requests, we'll do import Pyodide HTTP. And notice that as an import, it is a dash. This is the PyPI file, is a Pyodide dash HTTP. In your import, it's Pyodide underscore HTTP. And then before we import requests, we will do Pyodide HTTP dot patch requests. All right, and now if I've written everything correctly, what we should see is that in the browser as well, we're getting that same status code and dummy response from the API as we were getting when we ran Python in our terminal. This is super cool. So what's happening under the hood here is that when you do py.http.patchRequest, it's actually rewriting some of the methods of the requests library, requests package, to use the web native synchronous request methods instead of the Python native one. So Python's request package calls a thing called urllib3, which is a standard lib, and that has some sort of low-level network connectivity primitives in it. When you do py.http.patchRequests, the py.http package goes in and says, okay, anywhere we're using urllib3.get, put in XML HTTP request, because that's how we do synchronous requests in the browser, and so on and so forth. So it very cleverly rewrites this request library so that the rest of your Python code that you're used to writing can just work. There is also I believe, a patch for, I think urllib3 is also directly patched, and maybe the sessions library. Check out the documentation for py.http as a package on GitHub. It's really, really cool. And allows you to make synchronous requests in the browser using the request package, which is what people seem to want to do. Cool. So that's py.http. Let's talk about, next one's a quick one. Let's talk about the splash screen. So we've been staring at that quite a bit over the course of the stream. This is the spinner, the loading Pyodide, all these things that we've sort of gotten used to as PyScript developers. We've had some requests to be able to disable that for a variety of reasons. You know, maybe you don't want your users sort of looking at your loading screen. Maybe you're handling the loading process a little bit differently. So what I can do is just add make a mess of things, splash screen header to our pyconfig, and I can say enabled equals false. Right now, when I reload, we don't see the splash screen. We see just a blank screen until our previous Python code runs. So rerun that. We'll say reload, waiting, and PyScript, right? So splash screen, enabled equals false, works just fine to disable the splash screen. Now, one thing I did there is I put the splash screen header below the packages header, and that's on purpose. If I put splash screen above the packages header, now the packages attribute has become a part of this splash screen table, and I believe what we'll see is we start having errors. Yeah, so the module py.http is included, but is not installed. Why isn't it installed? I have packages here. Well, in TOML, and this is a little bit of a sidebar, but it's a common issue we see people having. In TOML, when you have a header like this, or like this, that header, there's no way to close this header, right? So in this case, once we've opened a splash screen header, every sort of naked key enabled packages, what have you, is now inside of this splash screen object within pyconfig. There's no way to say, like, close off this splash screen tag. This is not a thing. You could open another header. You could put a fetch config down here, right? And then, files equals whatever. But there's no way to say that this packages tab is not inside any header, not inside any table. The only way to do that is to move it to the start of your of your TOML file of your pyconfig, right? So if you're seeing errors in your pyconfig, you probably need to move all of these. I call them naked keys not underneath a header. You need to move those to the top of your pyconfig tag. Otherwise, they're getting swallowed up into some other object specified by a header. Yeah, of course, I've mucked things up by putting a fetch config there that didn't have any files in it. But once packages is now back outside of any of our tables, outside of any of our headers, things were just fine. So keep your naked keys at the top of your pyconfig tag, or use JSON. Cool. What else? Oh, another little thing. Let's talk about auto IDs. So clear this up a little bit. So let's give ourselves a little function to work with. Def foo print foo. That'll be our dummy function. Previously, if you were creating a button that had the Py click or any of the Py event attributes on it, you would need to do something like ID equals button. Previously, you were required to have an ID present for any object that uses Py events, Py-events. Now, you don't need to do that. So we can click this ID, recompile, and we should see this works just fine. Yeah, you'll see actually under the hood now what we're doing, if I look at this button, is we still need IDs on these objects sort of internally, but there's no reason we need to make the user supply them. So we're just assigning some internal dummy IDs to it if the user doesn't provide one. So little tiny change in the API. You no longer have to supply IDs when you're using any of the Py attributes. And this can be any Py event, right? It could be Py, let's see, Py focus. What can I put on here? Things like that. So when that object gains focus, so you can see it's not when it's clicked anymore, because I'm clicking lots of times, it's not happening, but it's just when if I focus somewhere else on the page by clicking and then click it again, when it gains focus, we run this foo function, right? No ID needed. One last little thing before we get back into some of the, I guess two more little things before we dive into some of the cool Pyodide updates, some additional cool Pyodide updates. This has been coming for a long time, but some of the elements that we have been saying are deprecated, like PyBox, like PyTitle, like PyButton, have been actually removed in the latest release. So these are no longer anything. I believe they won't even show up with a warning anymore. Yeah, so not only are they were deprecated for a cycle, now they are gone. If you're still using PyButton or PyBox or what have you, it's time to move on to the more modern methods that are described in the documentation. So go see the docs for those elements and things you might replace them with. I mean, they're not terribly complicated, right? PyTitle is essentially an H1 tag. PyBox is essentially a div. So not a hard transition, but something you should be aware of by now. And I should say one last little thing. PyScript now has a changelog. And if we go to docs.pyscript.net and go into our menu here, if we go into release notes, we now have a user-facing changelog for the major changes for version. This is a thing that we've been wanting for quite a while. It basically is the content that I would put in my blog posts or in these streams, put in a more official sort of local location. So that is our changelog. Go find it. Go check out what's changed. Once again, if you'll forgive me, I'm going to take a 2-second water break because describing PyScript with this much excitement makes my throat a little bit parched. I'll be back in 1 moment. Okay, see, that was fast. Didn't have to wait too long. And now we're going to get into some of the well, I don't want to say the more exciting stuff, but there's some really nifty stuff that's come out of Pyodide recently, including a bunch of new Pyodide packages included in their 2020 or their .22 release. So if I go to Pyodide's changelog, and we can just make this all very much bigger, and go down to their new packages, and I will make this bigger for you. Here is the list of new packages that have been included in Pyodide 22. Coverage Py, if you want to run test suites in the browser, is included. Bcrypt, part of the cryptography suite. Word Cloud for making visualizations. The Pyodide HTTP package is now Pyodide friendly, sort of Pyodide upstreamed, which is very cool. The hashlib module, which is part of the standard library now, got uploaded, things like that. So always cool to see new stuff coming. I should also highlight, so a thing you may not know, every version of Pyodide, right, the packages that are built specifically for Pyodide, every version of Pyodide ships with exactly one version of each of these packages. So when you upgrade Pyodide, you are committed to being pinned to a new version of some of their major packages. What this mostly applies to is things like SciPy, Pandas, NumPy, scikit-learn, and as they say, as well as most of the other packages. And you can check out the deeper parts of this changelog. This is because there are significant intercompatibility challenges with these various packages, and so and I should say with the Emscripten API, Emscripten being the program that compiles C and C++ programs into WebAssembly so they can run in the browser. So to ensure compatibility, each version of Pyodide is pinned to a specific version of each of the packages that it ships with, and so that's just a thing to be aware of as you're writing programs that interact and maybe require a specific version of NumPy or Pandas. You should try and make them as broadly interoperable as possible, because otherwise you may be stuck with a particular version of Pyodide forever. It's also worth saying each version of PyScript is intended for a specific version of Pyodide. though we try to be backward compatible as much as we can for a version or two, the Pyodide API is also changing continuously from one version to the next. And so we have, as the PyScript team, have essentially made the decision that each version of PyScript is intended for one version of Pyodide. So just something to be aware of as you are moving through an upgrade process. Some cool stuff that came in the most recent version of Pyodide are some of the ways that it deals with treating JavaScript objects like Python objects in a variety of contexts. So let me show you what I mean. Let's create here a script tag. And if you wonder why I keep looking over there, that's where my prepared notes are. So I want to make sure I get these things right. Let's create a JavaScript array. Let's say PyScript is great and cool, the world's most interesting array. So that is now a JavaScript array they've created in JavaScript. In Python, it is now possible to say, so from JS import, what did I call that variable? My array. And I can say print my array dot pop. Let's bring up our PyScript display on the side there. Oh, there's the change log. I guess I'll have to reopen my page. What we should see is cool, which is the last element of our JavaScript array. What's cool to notice here is at no point are we converting the JavaScript array to a Python list or tuple or anything. We are just accessing this object as a JavaScript object. In fact, if I say print, oops, brought up a fake terminal there, print type my array, after the fact, just to see what type Python thinks it is, it's still a pyodide.js proxy. So this is still a JavaScript object, but now JavaScript arrays have a lot of the methods that we'd expect Python iterables to have. So we can do things like myArray.append, sweet, and print myArray. So I can so now I should see that I've popped cool off the end of my array, and I can say PyScript is great and sweet, right? And again, we're not converting, we don't have to worry about converting this back and forth from JavaScript to Python in any way. The methods like append and pop are all implemented on the JavaScript array object already for us. What's happening, in fact, is that the JS proxy object of an array implements the iterable interface in Python. So we can even say for item in my array, print item. Right, so I can iterate over it in a very Pythonic way. See, PyScript is great and sweet. Because these JS proxy objects now implement the proper interfaces to be iteratable, they're iterables inside of Python, which is really cool. So some work is happening on the Pyodide side to make JavaScript objects, when they're brought into Python, feel as much like Python objects as they can. And one of those is making arrays and other iterable-esque objects in JavaScript truly implement the iterable interface in Python. The same thing is true of mapping objects. So I pre-typed this one just to make sure I get this right. If I have a JavaScript map, which is, if you don't know any JavaScript, is like a Python dictionary, right? It's a key value pair data set. Create a new map. A corresponds to 1, B to 2, C to 3, and it's here we'll from JS import my map, print my map. We can see our JavaScript object again, object map appears here, print type my map. Class JS proxy. So now, because this JavaScript map has some new attributes as a JS proxy, I can do things like for key value in my map.items, print key value. And I run that, and I should see A is 1, B is 2, C is 3, right? So again, my map is not a Python dictionary. It is a JavaScript map. In this context, it is a proxy of a JavaScript map. But because there are the things like items, like values, like keys are implemented on these JavaScript proxies now, we can just treat them a lot like we would sort of intuitively think we would want to treat them on the Python side. To be precise about it, mapping objects in JavaScript now implement the collections they implement the mutable mapping interface, which is a specification of things that mappings from some key to some value that are mutable should implement, and JS proxies of map objects do. So we can just kind of treat them like they are dicts or other things. Dict, of course, being the most common Python object that implements this interface. Yeah, so super cool. More and more just trying to be like, if people are bringing JavaScript objects into Python, how to make it as easy as possible for Pythonistas to interact with them in the ways that they are comfortable with, like this. One more nifty example is use of the match statement with JavaScript objects. So again, I prepared a JavaScript object in advance, create a variable called actor with some attributes. It's going to have a name, Keanu, role of Neo, and a singular function attribute called action, which is going to log to the console, I know Kung Fu. This is going to be our dummy JavaScript object for today. On the Python side, we can say from JS import, let's see. Let's just do import JS. We're going to need a few things from JS here, so we'll bring in the whole namespace, and we'll say pyactor equals js.actor. Actor was the name of our object. Yep, actor. js.actor.as object map. And this is going to create a similar, see, it's still a proxy, right? We're not creating a dict or anything from this object, but it's going to be a mapping from this object's attributes to the values of those attributes. So it's going to be a mapping that associates name to Keanu, role to Neo, and action to this function. Now, why would we want to do that? Well, that makes it really easy to do things like for key value in pyactor.items, print key value. Right, so we should be able to see all of the object's attributes and their properties. So I have name, role, and action here. And the action is actually smart enough to print out its source as well, which is pretty slick. But additionally, and this is what I think is really cool, we can use the match statement against this object. I could say case that it matches a name. Let's see, name is in this case a string key, and role of role. And I can say this actor name has the role. Now match is throwing up on me here. Why? Oh, it's because I'm linting against Python 3.9, but PyScript is running Python 3.10, so this linting error is just because I have a misconfigured environment locally to me here. But let's see. Let's create a fallback case. Case underscore print no match. And if we make this a little bit bigger, we'll see that so what we did is we took our JavaScript object, we created a mapping from the attributes to the values of that object, and then we can use Python's match statement to match against JavaScript objects in Python, right? So it knew this actor Keanu has the role Neo. If I go and take away the role, what we should see is no match. Right, so we are running a match. This is cool. I'm gonna be excited for a second. This is running a JavaScript object through Python's match statement. Right, the match statement is super cool and super powerful, and now we get to use it on JavaScript objects. How awesome is that? So some really cool possibilities coming out of what's possible with Pyodide. I should make this totally clear. This is an improvement that was made on the Pyodide side. That I'm just sort of demoing here because as PyScript largely relies on the Pyodide runtime, although put a pin in that because more development's coming. As PyScript largely relies on the Pyodide runtime, whenever Pyodide gets cool new features, I get excited about it because that means PyScript as a sort of a downstream project gets cool features too, and I want to share them with you because they're awesome. As usual, I've forgotten to update my little scroller down here. We talked about match.js. We can talk about venable promises in Python as well. That would be quite cool. Let's clean this up a little bit. Make that a little bit bigger. And we'll clean this up a little bit. So, what are venable promises? What are you talking about? So, if you are used to working in JavaScript in the sort of async way that JavaScript is typically written, you are used to using promises like so. Let's see if I can write a promise right off the top of my head. I can say, let's see. If I make this a module type, I can just run it. Type equals module, not pya, type equals module. I can say await fetch example.com or example.com, and then you would typically write .then, and you would do something else, console.log1, and you might actually write more thenables, .then, console.log2, right? Something like this. So if you're working in a situation where you have a promise that's then going to resolve, the JavaScript-ish way, what's the JavaScript equivalent of Pythonic? JavaScriptic? JavaScriptian? JS-ish? The JavaScriptian way of doing something after a promise is completed is to use these .then statements that basically say, when this promise resolves, when this async thing is done, then do something with it, right? That's a fairly useful linguistic construct. Do this thing, and once it's done, then do this something else, right? So this is a JavaScript concept, which we can now use in PyScript and Pyodide as well. And here's how. I'm going to bring in async.io, our Python library for doing async-ish things. I'm going to create a new function from JS, import fetch. We'll bring in that same fetch function to get remote content from. And I'm going to bring in a little bit of code that I pre-wrote just to make sure I got the thenables correct. Let's see. Why is this throwing up on? Oh, from JS, from Jeepers Creepers, from JS, import, fetch, oof. So we're going to bring in our JavaScript fetch capability, and then we'll do a similar thenable, but from within Python. So we'll say await fetch from some dummy location. Then, once that has returned, we will use its result x and get the JSON representation of it. And once that is complete, then I will get the name of it from its info parameter, and I will return that as my name object and then print it out, right? So to be clear, this fetch is creating a promise on the JavaScript side, and we are what is being added in this new version of Pyodide is that we can now use this .then function inside of the Python side of things. And what's more, the function that we pass to then, sort of what we want to do once the promise is resolved, we can use Python functions for. We can use things like lambda instead of having to import a JavaScript function to do it. So if I run this, and I hope it works. Oh, well, I would of course need to actually run our async function, async.io.ensure future demo. We should see PyTest, which is what we'd expect. That is the name of the Python package that we've gotten from the PyTest repository on PyPI, which is cool. If I perhaps get the JSON output of it as well, we can see we're getting that intermediate result. Oh, JSON is just an object, so we would need to actually, de-JSONify it and print it or something. So yeah, so this is a cool new advance. If you are someone who is working with JavaScript and with Python both, we now have the ability to use this .then functionality on JS proxies inside of PyScript. That seems like maybe a little bit esoteric when I word it out that way, but if you're used to working in JavaScript, this .then syntax is the way you're used to sort of naturally working, as opposed to like adding a callback function manually. It's essentially what .then does. So that's very cool. It's a nifty thing that, again, Pyodide has added and PyScript... Well, Pyodide has added and I am excited about. I don't know if PyScript is excited about as a category. I am excited about it. I think it's very, very cool. JS proxies, the way that JavaScript objects are being brought into Python continues to get smarter and more clever, and I'm thrilled about it. All right, so that is, I think, all the big new stuff that is here in PyScript 2023.03.1 and in Pyodide 22, but don't go away, because I want to wrap at you for just a little bit about what's coming up next. And I know I did this last time as well, and there was a lot of stuff that was like, yeah, this is coming, this is coming. There is a ton of work happening on everything I'm about to just talk about, and I expect most of it to be in the next release, which is coming soon. I cannot tell you just how hard the PyScript team is working on some of these really cool features, and I'm so excited to get them into the code base and get you all playing with them because they are all useful and super powerful. So let's dive right in. What is the first one on my list here? Workers. Okay. So this one we've been talking about for a little while, and let me give you a little context before we look at some of the code. A thing you may know is that in the web browser environment, every browser tab has one thread associated to it. Thread in the sense of like a process, well, not a process, it's a different thing. An execution timeline for your code. You have one thread. So if you do something like, let me open up my Python file again, I can demonstrate this for you. Print 1, close my dummy terminal here. Well, let's just make sure that works. Printing 1 should work. Yes, very good. Print 2 should work. Oops, it would help if I showed you the code. You didn't really miss much. We had print 1 and print 2, and that works just fine. If I now do for underscore in range 10 million, and let's pick some dummy variable here, x equals 1, it's going to take a little while for that to complete and for the results to show up on my screen. And interestingly, if you were running, what you might expect to happen is that we would see 1, then a little bit of a pause, then 2. But that's not what's happening. We're seeing a long lull, and then 1 and 2 appear at exactly the same time. So what's going on there? Well, currently, in the current release of PyScript, the function which says, hey, go run this Python code is a function call. It's a synchronous function call. And so it goes out and says, hey, run this 4 lines of Python for me. And PyScript says, sure, I'll happily do that. But it doesn't return or seed any control back to the main browser thread until it is entirely complete. So what PyScript is doing is saying, okay, send a message to the browser to show the characters O-N-E on the screen. But it says, schedule that for when you have a chance. But before you do that, I am still a singular function that is running. I have to run this useless loop, and then I print 2. And only when all of the Python is done running does the browser get a chance to do anything else. Update the DOM, do any communication, anything like that. Right? So if I increase this to 50 million, to make it a little more obvious, right? It's gone out, said, run my Python. And Python is saying, okay, yeah. Schedule putting this on the screen, schedule putting this on the screen. But the browser thread has no opportunity to do any of those things because we're literally locked inside this for loop in the singular thread that we have until this is done completing. Here, let me kick this up even a little more to make it a little more obvious. If I come over here, like I'm trying to right click and show you the Explorer. I can't even do that, right? All of the interactivity inside this one browser tab is on a single thread, and that thread is currently looping 100 million times over this assignment, and only when it finishes, actually you can see there, yeah, so it printed 1 and 2, and then it tried to handle all the right click events that it had from there, and open the, the inspector and things like that. It can literally do nothing because there is exactly one thread to handle it. This is not ideal. If you were running Python in a desktop environment and you'd written a loop like, loop for 1 to a million and it was taking too long, you would want to maybe break out of that loop, maybe hit your Command C and just be done with it. But that's not possible in the web browser environment natively because there's no additional thread to get that message to tell the first thread that it should stop running the Python. Similarly, we might have a very valid reason to do some long-running computation here, and it's a real shame that we prevent the browser from doing anything else when this is happening, right? This could be, maybe we're taking some user data and we're running some convoluted matplotlib computation over it, or we're calculating a very big data visualization. If it's, something on the order of a few seconds, literally nothing else can happen in the browser thread until that completes. This is not ideal. The solution is what's called web workers. For a few years now, browsers had the ability to allow a single tab to spawn additional threads to do this kind of work for them, right? They to do things like heavy computation, to do things that you don't want to be blocking up the main thread. You want to spawn an additional thread, go do some work, come get the answer, and bring it back to the main thread, right? That is the idea of a worker thread. And so this is something, obviously, that we're like, this would be a great thing to incorporate into PyScript and Pyodide so that you could say, hey, run all of this code in a separate thread, and when you're done, I'll take the result and do something with it. And it's the take the result part where things get complicated. One of the limitations of code running in a worker thread is that you don't have access to the DOM. You get access to a lot of JavaScript sort of primitives, right? You get access to things like your transformers, your string methods, your array class, all these things you get, but you don't get access to the actual contents of the page, of the document, of the body of this page that the user is working in. And that's a little unfortunate because that's really what we are interested in interacting with as end users in the browser, of course. So you could run Python code in a web worker and not have it interact with the page. And in fact, this is what something like Jupyter Lite is doing. If you ever use Jupyter Lite, which is running notebooks in the browser environment, they are spinning off Pyodide, actually the Pyodide runtime, into a web worker, getting the calculations out of it, getting the results, and then when it's done, porting sort of the text contents of those results back over into the main thread and printing them on the screen. Right? That's very feasible. But we in PyScript and Pyodide land have become really excited about the possibility of DOM interaction, and specifically DOM manipulation and events. So for those who are brand new to PyScript, and I applaud you for being here this long into this video, if you are brand new, good on you. We can do things like this. Let's create a new element with the ID foo, and when PyScript runs, I'll say my lm equals this element in the document, my lm dot inner text equals goodbye. Right, so when PyScript runs, it's able to grab a reference to that element of the DOM and change properties about it in real time. Right, that's what I mean by DOM access. And by DOM events, similarly, the way we were using PyClick earlier, or things like that to respond to events happening in the DOM, because currently Pyodide is running in the main thread, PyScript can respond to those as well and take actions or send events to the DOM or something like that. Code running in a worker thread is not able to access either of those systems. You basically get standard in, standard out, and that's it. Until now. So let me show you, and this is going to be a little bit wild. I'm going to make sure I'm on the right Git branch, and I will show you, where are we? Origin main? Yes, we are. Let's make sure, I'm just going to do another quick poll to gosh, I'm making a mess of this. What I will do is check out the PR that is currently in the works, and we'll take another look back at the main main.ts file that we were looking at earlier. And you'll see the constructor even looks quite a bit different than we did earlier. But the thing I really want to look at is some of this. So once we've done our configuration, once we have done a couple things with our plugins, what we'll do is I'll load our Pyodide interpreter. And this is the sort of meat and potatoes of this. Rather than loading up the Pyodide interpreter into the main thread, we load it up into a worker thread. We spin it off and say, hey, Pyodide, go do your things over there. But then, using the sync link library, which is something that I believe was originated and is being maintained by Hood, who is now a member of the PyScript team over at Anaconda, we are establishing a proxy message queue in between the main thread and the remote thread that allows the Pyodide interpreter, even though it's running in a separate thread entirely, to still be able to get access to proxies in the main thread and pass them back and forth. This is really cool. I can't run a demo of this for you right now because it's still very much in development. But the idea is that you have your Pyodide interpreter running in a worker thread, and when it needs to access the DOM of the main thread or some event from it, it gets automatically sort of passed back and forth by proxy. The upshot of this is that you'll be able to write Python code to run on a PyScript tag that could run remotely in a worker thread in a non-blocking way and still have access to elements of the DOM, events that you want to listen to or control, things like that, which is really, really kind of amazing. It's kind of like magic. I will say there is going to be one limitation to those who can use this. Let's see, where can I show that? Send my headers. So one of the cool things about PyScript, right, is that you can basically drop a script tag into any HTML document and PyScript just works. And that will always be true for Python running in the main thread. It will not quite be true for those running PyScript with Pyodide in a web worker in this non-blocking way. In order to have this proxy link between a remote thread and main thread, which you can imagine is it's slightly worrying for a couple of, it's not a huge issue, but we're basically opening up a channel of communication between a worker thread and a main thread in a very primitive way, that we are allowing them to access some same chunks of memory, literally a shared array buffer between the main thread and the worker thread. And so in order to do that, all browsers, and especially Chrome, which is one of the ones that allows this, say, hey, you can do this, but I'm not going to allow this page to then pull in just any resource that it wants into your page. If you're going to allow multiple threads to share the same memory, we are going to put some limitations on where exactly your content is allowed to come from, unless you tell us otherwise. What that means in real terms is that the server that you host your HTML file from will need to have a couple of additional headers set for it. Specifically, the cross-origin embedder policy must be require corp, and the cross-origin opener policy must be same origin. And these basically say, by default, any scripts that are loaded onto this page must have a cors allow all header, or allow this source header. Like basically say, any resource that gets pulled in must be allowed to be pulled in. And any script tags that you have in this page will need to be either from this same server, from this same origin, or you'll have added, I think it's a cross-origin attribute to that script tag to say explicitly to the browser, hey, I know these headers say I shouldn't be loading anything else, but this one script tag, load it from somewhere else. That's a very loosey-goosey, hand-wavy way of describing this issue. The upshot of it is you will always be able to run PyScript with Python in the main thread. If you want to run it in a worker, you'll need to run it in an environment that has these two headers set. They're not hard to set, and we're updating the docs to say, like, when you run PyScript, if you want to try this, you can do this with a Python script, the same way that we have always advocated, like just run Python -m http.server, right? This has been our sort of recommended way of opening a live server to do PyScript development. There is a modification of this, a simple script that allows you to, run a local server with these headers and try it out. It's not a huge lift, but there will be a few environments where it's not possible. So we think it's worth it for the trade-off of being able to run code in a separate thread and not block the main thread, but that's the trade-off that you're making sort of in the browser environment there. Yeah, super excited about workers. I hope to be honest, I hope to understand it myself at a slightly deeper level by the time it makes it out into the release, so that when we do this stream again in weeks when that release comes out, we can talk about it in greater detail and what the limitations are and how you get the benefits of it. So that'll be very cool. What else? A couple more things. Wow, this I can't, it's like my little headers down here just continue to sneak down the page. Or is it my window that's sneaking down the page? Get out of their window. There you go. We'll talk about a couple more things here that are big advancements coming in the future. So we used some functionality earlier, like click me. And we use the PyClick attribute. And inside of PyClick, I put in things like foo, an actual executable string of code that we were then going to run if we had def foo something in our Python file, right? That's the way that PyClick and its other attributes, PyHover, PyBlur, whatever browser event you want, has been there. We've been treating this as an executable string of code. We literally were behind the scenes calling exec on your code. So this could be something that has multiple statements or expressions in it, right? Could have a couple copies of foo, could have bar, things like that. We are going to be making a change to this API in an upcoming version, and I want to throw it out there to you, all you good nerds who are watching, so that you're ready for it. And if you have feedback on it, there's actually an open PR that Mariana is managing right now that you can go and leave feedback on if you would like to. So the way that this is changing is like so. In an upcoming release, there will actually be the PyClick will no longer take a string of executable code. It will take a reference to a handler. It will take essentially a function name or the name of a callable. This is more in line with what a lot of JavaScript web frameworks do, like React or Vue. This is not an executable string. This is the name of a callable that we have defined somewhere else, right? But there will be one other option. This will work. I'm just going to write the Python code in below it here so you can get the idea, right? This could be my definition. I could say def foo, but we're also enabling you to write def foo of event and then use that event inside your function somehow. Print event dot target. What's going to happen under the hood is that PyScript will, when you call this function, look at the callable that you've passed. If it takes no arguments, it will just call it. If it takes a single argument, and that argument could be anything, right? It doesn't have to be called event, but event is probably a good name, because if your callable takes a single argument, the event generated by this JavaScript event will be passed to your handler function, right? So if you need to be able to say like, oh, when I call this function, grab the object that is the target of this event, that could be event.target or something like that. So we'll do a little inspection for you and handle both of those cases. The way that is, actually, let's leave that on screen so we can do some comparison here. The other extension to the PyEvent API that we're making is the dash code extension. So similarly, this click here could be hover, could be blur, could be mouse over, whatever you want to do. I'll leave it as click just for illustrative purposes. If you do pyclick dash code, what you provide there is still an expression of code to execute. It's no longer a string of executable code, right? We wouldn't be able to put multiple expressions in there. You get a single evaluatable expression that is evaluated when this event occurs. So why do this? And a lot of people have asked, like, why do you want, like you generally don't want users to have access to, like, calling eval on some string that they are just providing to you. And the example that sort of tips it over for me is something like this. If you have, let's say, a square of color on your screen, you might want to write a Python function like this. Element.color equals color, right? That somehow sets the color of this box on my web page to a specific color that I provide. And I would like to have 3 buttons on my page that set the color of that box to 3 separate colors. The sort of natural way, I think, to write it is like this. When I click the green button, call foo with the argument green. And this is all loosey-goosey, right? Green is an enum, or I don't know what it is. Maybe it's a string. But I want to call this function setColor. Really, setColor is what it is. SetColor with these 3 different arguments. If you only are allowed to pass a callable handle, right, there is no natural way to pass arguments to this function. I mean, yes, you could wrap it in a partial. You could do foo of green, but partials are kind of an advanced topic, right? Like they're the way that they turn a callable object into a different callable object right now are kind of far down the rabbit hole in terms of Python. Really, if you're a new Python writer, you want to be like writing a function that takes an argument, like, call this function with this argument. And that's what this dash code extension allows us to do. It basically says, when I see this event on this object, evaluate in the global namespace this function. Right, so, and this is true, again, for any of the events. So this could be mouse over. This could be blur. This could be, change if the contents of your input object changes, right? So the difference here is not what events are available. The difference is the sort of naked events take the name of a handler. If it takes no arguments, we just call it. If it takes 1 argument, it gets past the event. If it's the event with dash code, then it is an evaluatable string that gets evaluated in the global namespace when that event occurs, right? To allow for both of these use cases. This is, I think, is going to give us a lot of options in terms of the way people write code to control their site. Sometimes you want to just eval some code. Sometimes you want to have an event handler that's handling some past event in your page. So I think that flexibility is going to be good. Sort of behind the scenes, to give you a little taste, for a long time, we had been dallying around like, what if they were both just the same syntax, and we did some inspection to figure out like which case we were in. And that feels a little bit like overloading this syntax by a little bit too much, and that's where the dash code extension came from, is to specify, okay, the events are for specifying handlers, the dash code is for specifying strings of value, evaluatable code. You give code, you give the event a handler. Right, that's where that came from. So a little update that's coming there that I'm excited. I shouldn't say little. It's quite a big update coming there in a future release that I am quite excited about. All right, one last thing, and then a teaser for next week's stream that we'll get to. Is the Pixel and SDL integration into Pyodide. So I'm just actually gonna, full self-promotion here. I'm gonna go over to my blog and that post that I wrote that is linked in the description below for what is new in PyScript 2023 03.1. The folks over at Pyodide have been experimenting with a build of Emscripten that allows SDL to interoperate inside the browser. SDL is Simple Direct Media Layer. It is a broadly adopted API that allows for your program, your Python, your C, your Rust, whatever, to interact with whatever multimedia type objects your operating system has. So on your computer, that's your graphics, your inputs and outputs, that's your sound playback, that's your mice, keyboard, joystick inputs. You have a single common API that you can write for, and then SDL runs in a lot of different environments: Mac, Windows, Linux, and now in the web browser. So this is something that some of the folks who write Python libraries that rely on SDL have been working with for a while, basically compiling their libraries like Pygame, like Pixel, to WebAssembly. So you could write a program that's meant to run on your desktop and then use some functionality to compile it to WebAssembly so that it could run in the browser. And the folks at Pyodide are now experimenting with adding this SDL support into the version of CPython they compile into that environment. So these programs like Pixel and Pygame and stuff just work inside of instead of PyScript and Pyodide. The upshot is that it is now really easy to write games, or will be, I should say, when this update happens. It is really easy to write games that are meant to run inside of your native desktop environment. They can run directly in your browser by way of some of the libraries that enable. Oops, I've run off the bottom of the screen there. that run in these libraries. So this is a little dummy game that I wrote called Wasm Wabbit that runs. This is a game that is written in the Pixel game environment and is running in my browser via Pyodide. So, running games in the browser, this is something we've been able to do since Shockwave Flash. You're like, what's the big deal? Well, I'll show you the big deal. If I open the repository for Wasm Wabbit, which I believe I have here, it is simply a Python game. Right? It is written the same way that any other app you would write for Pixel is written. Right? There's nothing special about it to run it in the browser. I basically just load the Pixel library in Pyodide, load this code in, and it just runs. Well, there's a couple tiny caveats, but it basically just runs. And this is really cool. So users can now write games in this Python framework, which wasn't intended to run on the web, and now it can run directly within Pyodide. And that is super cool and super powerful. But it gets more powerful still. So I should say the Pixel team especially has had a build tool, a compiler for a while that allows you to build your Pixel game into WebAssembly. Right? You take your Python app, you compile it to WebAssembly. It creates a little WASM file and a JS file. You drop that in your website, and boom, Pixel game on the web. That's not the new feature. The new feature is that it integrates with Pyodide, and Pyodide has access to all these cool things that happen in the DOM. Right? We have our whole JS Python interaction. So now, not only can I play my game in the browser, but I have all the interactivity that is built into Pyodide. Like, for example, in this game, I've set up a listener on the browser window so that if the window loses focus, the game is automatically paused. Right? Things like that. So we can sort of do any of the sort of browser window interaction that we're used to from Python and Pyodide. That is all now immediately available inside of these engines because they're running within Pyodide. Similarly, and this would take quite a while to show you, but you might have noticed earlier when I beat this level in record time, because I'm a very good gamer, as you can tell from my Twitch-like presentation here, it's timing you. And when you complete the I think it's 4 levels of this game currently, when you complete that, it will not only tell you your score, but it will save your high score to your local storage in your browser, in your cookies. And if you come and play again, it will see if you can beat your high score, right? All that sort of like browser window interactivity that we have is now just freely available in Pixel. In this game engine because it's running within Pyodide. I will show you just briefly how that works. Here's the pause functionality, right? All it's doing is as soon as I'm sort of loading the game, I say init, I say if Pyodide insist.module. So if this game is running in Pyodide, then add an event listener that when I lose focus on the window, pause it, and if I gain focus in the window, unpause it, restart the game. What's cool about this is that this game also runs just natively on my desktop. I can do Python main.py, and this game will run on my desktop. But if I run it in a Pyodide environment, if I run it in the browser, now I get this extra functionality provided by Pyodide. I am super excited for the possibilities of making games for the web. that are going to be opened up by this. Pixel has kind of been the test dummy for the PR that's currently in draft for adding SDL support to Pyodide. But I know the folks over on the Pygame side of things are super excited about it as well. Pixel is like a little bit more, because it has this sort of retro RPG, retro game vibe. The API is somewhat simpler, it's somewhat easier to test, doesn't have quite as many features, and that makes it a really good candidate for this kind of thing. But once that SDL integration happens, Pygame is going to follow very quickly, and other libraries for games and other media production are going to follow along really quickly after that, which is really, really cool. So yeah, get excited about making games for the web in pure Python. That's going to be really nifty. That, I think, is all for this week. I will tease, if you've made it this far through the stream, thank you for sticking around, that I will be, I am planning to have a stream next week at this exact same time, 11 a.m. Chicago, 1600 UTC. I cannot tell you just exactly yet what that stream's topic will be. I know it. I'm just not allowed to tell you. And I hate to be a tease, but it's not my pinata to pop. But keep your eyes on PyScript news this week. Come hang out in the Discord or follow PyScript Dev on Twitter to see what's coming down the pipe, because there's some big, exciting things happening in the PyScript world that I am planning to talk about next Sunday right here on the stream. If you don't want to miss that, you can subscribe, you can hit the bell, you can like, you can do all the things that one does on the web. I assume if you are 2-ish hours into this very dirty stream, you are a web native enough to know how to be reminded of things happening on YouTube. But in the meantime, I would just say thank you for hanging out with me on what is for me a Sunday morning and checking out what is new in PyScript 2023 03.1. It's been a pleasure having you. As always, if you need help, if you have comments, issues, concerns, come to the Discord, linked in the description below, and we will do our level best to help you. If you find a bug, show it up on GitHub. And in the meantime, happy coding. Thanks so much, y'all.